Hello everyone. In the last session, we have seen the questions and their solution of the 2021 IIT JAM chemistry problems. Okay, so I have discussed 1 to 9 questions. Okay, and here is the 10th question onwards. Okay, so if you wish to comment or if you have any doubts, you can mail me. The mail link and everything is given in the description box. Okay, let's get into the session. So it is about the pKa. Okay, so pKa of the carbonyls. So actually the carbonyls of the cobalt which are with hydrogen can be able to liberate the proton so that they can act as a acids. Okay, they can act as a acids as the anion that is going to form will be stabilized. Okay, so this is the uh, here is a series of carbonyls of the cobalt is given where the ligands got replaced with different kinds. Okay, so if you can see the references, so this is what the reference, okay, based for the carbonyls of the cobalt. Okay, so when it is a tetracarbonyl system, it is 8.2. Okay, and if it is replaced with the triphenyl phosphine, okay, when a carbonyl is replaced with the triphenyl phosphine, it pKa is increased to 15.4. Okay, pKa is increased to 15.4. This is because the increase of pKa indicates decrease in the acidity. Okay, increase of pKa indicates decrease in the acidity. When the anion that is going to form from the liberation of the proton, if it is from the tetracarbonyl is this, if that is replaced with the one of the triphenyl phosphine ligand, which is a more donating in nature. Okay, as it is the anion that is going to form with the liberation, and if it is attached with the more donating group, that will be very unstable, so that its acidity is going to decrease and the pKa is going to increase. That's why it will be 15.4. And if it is replaced with the ophenyl, okay, oxyphenyl, so it is little bit withdrawing in nature because of the oxygen, so that it is not that extensive of the triphenyl phosphine electron in the electron donating nature. So the pKa is little increased when compared to the carbonyls. Okay, so if I go back to the question, let's look into this. So here it is 8.2, and if it is replaced with the one of the phenyl, it is 15.4. If it is oxyphenyl, it will be 11.4 or something. Okay, so if one triphenyl phosphine gets the position of the carbonyl, it is become almost double. If two triphenyl phosphines are replaced, then it will be even higher when compared to this. Okay, so 4 is the maximum, then 2, then 3, and then 1 in the pKa order. If it is acidity order, it will be reverse. Okay, 1 is most acidic, then 2, then this is 3, then 3, then 2, and then 4. Okay, so our interest is about the pKa, so like in 4, then 2, then 3, and then 1. Okay, so this is, so hope you like. So if you need the reference, go for this web organometallics journal. Okay, so you can find here the complete details of this, and you can find also the explanation, okay, in detail with the replacement of each phosphine ligands, okay, and each carbon. Okay, so this is the explanations for complete groups. Okay, so hope you like this session. Okay, so let's go back to the next question. So this is what based on the enzyme system, metalloenzymes. Okay, so cytochrome P50 catalases galactose oxidase and cytochrome C oxidase. Okay, So if you can see cytochrome P50, it will convert the alkane into the alcohols. Okay, alkane into the alcohols. Okay. So in which of these reactions it is alkane to alcohol? So it is N. Okay, this is alkane which is converted into alcohol. So it is N. Okay. Next, catalases are the uh, can convert the hydrogen peroxide into water. Okay, so K is the best suitability for this solution. Okay, next, the galactose oxidase will convert the alcohol into the aldehydes. Okay, so galactose oxidase will convert the alcohol into the aldehyde. Okay, so you can find all these reaction in the uh, biochemistry or biosynthetic pathways book. Okay, or you can also see in the bioinorganic chemistry details. Okay, so try to find the reference books. This is all refer in different standard books. Okay, so which is just based on the standard books, so it will be the accurate answers. Okay, so cytochrome C oxidase will convert the oxygen into the water. Okay, so this is what. So your answer will be NKLM. NKLM. So option 4 is correct. Okay. Option 4 is correct. Okay. Next. So for this, after the calculation, you will get 0. Okay. So because if you work out all this, it will be equal to the 0. Okay. So next. So this is pretty good organic synthetic reaction. Okay. So in this with the base it's going to give Michael addition. Okay. So to the carbonyl. So this is going to attack here. So it will be this. Okay. So resulting will be O minus and COOET and COOET. Okay. So here it is hydrogen. If I write, I didn't write also, it will be the same. Okay. So next, it will abstract the H place, okay, from the system which is liberated, okay, which is liberated. So that will be acquired. So I'm trying to write little shortcuts, okay. So try to understand. So if it is abstract the H place, it will become OH, okay. So once it get turned into OH, so this H plus and OH will be eliminated, okay, in presence of base, okay. So it's going to become this, okay. It's going to become this. So in the first step with this, okay. Now the attack of second reagent, that is dimethylamide, okay. So if it is attacking, it's going to convert to this, okay. So it will be N dimethyl with H and this place. So hydrogen will move to this, so it become neutral, and at the same time COOET and COOET. So when this bond is migrated, it become minus. That will be going to abstract the H place. So it will be neutral. Okay, this is going to happen. Okay, so after this, when it is reduced with the lithium aluminum hydride, okay, so you might be facing difficulty with my handwriting. So I'm trying to make it little bit better version. Okay, so let's see. So lithium aluminum hydride will convert the ester into the alcohol. So it will become CH2OH and CH2. OH. Okay. Once this gets treated with the Lewis acid in presence of aldehydes, it will be going to form the diol protection or cyclization with the aldehydes. So this. So the final product will be this. Try to locate the final product. So this is open chain. That is my that might not be possible. Oh, I did a mistake. So the starting material is with the pyridine, not the benzene. Okay, so that's not big botheration. Okay, so this is. So let's look into. So no cyclization product is going to form with 5 member. It will be with 6 members. So option B is also ruled out. Option C is without the aldehyde protection. Okay, so this is also ruled out because in the last step we have used BF3 with the aldehyde. Okay, formaldehyde. So that's going to protect. So the fourth option is exactly matching with the product. Okay, so this could be the our answer. Okay, so option 4. So if you have any doubts or if you need to comment anything, just try to comment on the comment box, or you can directly write the personal mail to my Gmail address. It is krishnashiva629backup at gmail.com. Okay. So this is based on the Cram's rule. Okay, with the attack of the nucleophile, as the nucleophile is smaller one, H minus hydrogen nucleophile is going to attack on the carbonyl. There would be the two possible condition. The carbonyl group is a planar one. Hydrogen can attack from the back side, okay, and can from the front side, okay. So these two attacks may change the stereochemistry of the group which is going to form in the product. So generally the hydrides will convert the carbonyl into the alcohol. Okay. So your product is simply alcohol. Okay. So but the thing is it is asked for the stereochemistry. So as the methyl group is towards the us or it is above the plane. So the attack of H minus from the above plane is ruled out because it is going to give steric repulsion. So that H minus hydride will attack from the back side of that, so that it becomes it will flip onto the other side. So the product will be going to the O minus. Okay. So as the hydrogen attacked from the sorry hydrogen is attacking from the front side, so oxygen will become like this. So this will be the O minus and here will be the hydrogen. Okay. So the backside hydride is attacking. So after this with the methanol is going to abstract the proton. So this become OH. Okay. So this is the final product that you need to find out from the option. So the first option itself is given with the correct option. So this. Okay. So next. So this is from the exactly OHI book. Okay. You can find out in the OHI book in the cages and complexes. Okay. So rings, cages, and there is a chapter. So in that chapter it is given. So the reactions are also given. BCl3 with NH4 Cl at 140 degrees centigrade, it will be going to give B3N3H3Cl3. Okay, Cl3. Okay, this on reduction with the sodium borohydride. Okay, this on reduction with the sodium borohydride. So it's going to give the product of borazole B3N3H6. Okay, so this on water hydrolysis, okay, is going to give diboran B2H6 along with the ammonia, okay, ammonia gas. So the question is given that BCl3 and NH4Cl are treated, okay, to give the P. So this is what P, okay, here it is the P, and NaBH4 treatment it is given the Q as a liquid. So this is what borazole or Borazine is given as a Q. Okay, and this is with the hydrolysis. It's going to give R as well as the gas. Yes. Okay. So let's look up. So P B3 and 3. So there is no oxygen. So it is not possible. So I'm sorry. So P. So P is not the Borazine. Okay. So it is Q. So I can rule out this. Okay. And R is this. It is diboron. So I can rule out this. Okay. And Q is so S is ammonia. It's not this. Q is also Borazin. This is also not. This is P. So this is not there. Okay. So just give me a minute. Okay. So here with this before the formation of diboron, there will be the formation of BOH NH3. Okay, taken thrice. Okay, so where the H minus are going to replace. Okay, H minus is going to replace. Okay, so once it is going to broken down, so it's going to release the B2H6 as well as the NH3. Okay, so in this this complete reaction is given in the UHI book. Okay, but it is skipped this intermediate. Based on that only it is given the question. Okay, so the R must be this. Okay, so the other R all are given in the UHI. Okay, so you can find it. Okay, so P will be B3N3H3 Cl3, okay, and Q will be borosine, okay, and R will be this, okay, S will be NH3 gas, okay. So that's all. Next question, okay. So here are many other questions. So I'll try to continue with the next session, okay. So this is the last question. So here I'm giving small sessions because it will be going to comfortable for the uploadation as well as the comfortable for the viewers also. Okay, so I I could able to solve more than 45 questions. Okay, so till the completion of all these session, I will be going to give complete solutions for all the questions. Okay, so let's go for the 18 electron rule. Okay, so 18 electron rule basically is of pseudo electronic configuration. If any molecule having 18 and 18 multiples, that will be going to have highest stability. Okay, so let's look up the tantalum one. Tantalum atomic number is 73. Okay, and let's say this is 73 Cl plus 3 electrons, and this is neutral one, so 2 into 2 it will be 4 electrons. Okay, and this is CH C trimethyl. Okay, so it is going to have 2 electrons. Okay, because it is like this. Okay, so it is 2 electrons. So total, so 73 plus 3, 76 plus 4, uh, 80 plus 2, it is 82. Okay, so if it is 18 multiples, it will be 86, not 82. Okay, so this is not obeying the 18 electron rule. Let's look up the other. Okay, so this is 5 electrons, F-tacity is 5, and titanium is 22, and 4 carbonyls each is going to give 2 electrons, so it will be 8. So 30 plus 5, 35, and 1 minus charge will be going to add up. Okay, so it is 36. Okay, next this is 5 electrons and iridium, I think 77, and CH2 2 electrons, and this is neutral, so 2 electrons. Okay, so 4 plus 5 9, and 77 plus 9 it will be 86. Okay, so this is also obeying. Okay, next manganese 25 plus, this is neutral, which is very similar to methyl group. Okay, so it is 2 electrons, and 4 carbon is each into 2 electrons, so it is 8 and 1 minus. Okay, so 25 plus 1, 26 plus 10, it is 36. Okay, so all are obeying the 18 electron rules except one. Okay, so this is why. Okay, so hope you like the session. So keep watching. So I will be going to upload the another session in 5 to 10 minutes, so that you can find the most of the 2021 chemistry questions with complete solutions. Okay.